Hello, so my name is Tim Berquist. I'm a graduate student at the University of Washington in the Department of Biomedical Informatics. So I've been working a little bit on this. I got roped into doing data quality about a year ago, and I was at the last tutorial for those of you who were here, and I was showing the first version of this tool that we had that I had adapted to OMOP. And over the course of this past year, we've made some changes, kind of revamped it, re-engineered it, made it a little easier to customize and add new test cases to. And so I'll be kind of introducing that. Just keep in mind, so it is a data quality assessment tool, but I think it also would fall a little bit under data characterization. I know that's a gray line on where that actually breaks off, so I'll let you decide what you think it is. So anyway, just for some context, so originally this tool was developed to help with the DataQuest project. And so University of Washington is part of the WWAMI region. This is Washington, Wyoming, Alaska, Montana, and Idaho. And this is just a big collaborative that helps combine both the medical school as well as clinical practices across that region. And so DataQuest was in charge of combining all 60 plus primary care clinics across the WWAMI region together for research purposes, to do randomized control trials and comparative effectiveness. And so DataQuest represents over 250,000 patients across this region. So the way they were combining all this data was 20 data-connected clinics in the WPRN. They would pull the individual data sets individually from the clinics, try and harmonize and standardize them into the OMOP common data model, and then put them into the singular DataQuest repository for future research use. However, as many of you probably find out, when you pull all this data in, you start distributing it for research, you get a lot of feedback from the researchers saying, this isn't right, this isn't right, this isn't right. And so they decided they needed some sort of data quality tool or some assessment or characterization just to try and understand what is going wrong with the different data sets. Another thing is, I don't believe DataQuest was doing their own ETL. They were working with a third party. And so that can add in other problems where if you discover a data quality issue, it's hard to characterize that and then send it back to the third party to hopefully get back your correct data. So they really liked the framework that's been now plastered up here multiple times at this point, and so they tried to conceptualize their data quality tests around the CON framework. The main problems they were facing early on was around completeness, and so that's what the focus of this tool is assessing completeness and presenting that information in a digestible format. We do have a couple conformance and plausibility tests in there, but the main focus is completeness at the moment. And so this is just a quick rundown. I'm going to run through each of these and how we digest them and how we present them to people, but just for your future reference when we send the slides out, you can check these over. So the original tool was developed by Hassan Astiri under the guidance of Carrie Stevens, who is the PI for DataQuest. This was all in R, and it was mainly just for assessing completeness. The main issue we had originally, though, and as those who last year were working with the tool going to test, all these different modules were intertwined with each other. There was no overarching architecture that could allow for easy customization on each of these modules. And so any small change you made in one of these modules just kind of broke the whole thing. And so we've been kind of rethinking about how to make this tool a little more easy to use and easier to customize. But essentially, the basic use case is the same. So with the version 2, we've reformatted everything, we've re-architected, and we've separated out each of the data testing modules into their own separate self-contained modules that will just use one object to run all the different tests. So when you download this tool from GitHub, the first thing you would do is just open up your config.json file, and you would just put in all your different credentials. So what database management system are you using? What common data model are you using? Just the very basic information. And then you would just run a simple command. It's a Python tool, so you just run python dqec.py, and then you'd link in the path to your configuration file. And then you would just run. You would just run all across your OMOP database and return a nice dashboard. So I'm just going to walk through each of the different modules that we use. So when each of these run, they output a report into a CSV file that's stored in a reports folder. And then at the end, we combine all of those together into a single HTML visualized report that you can run through at your own leisure. As I go through each of these, I'm going to show the different visualizations we use and how these can be used to track down different data quality issues. So the first one, this is just a very simple check. It compares what you have in your database to what you'd expect to have in your database. So we have a kind of a gold standard, for instance, like OMOP version 5.0, that we would compare your database against to see which tables you're missing, what columns you're missing. And we could visualize that pretty simply in a couple different images. So in this image, you would just take a look at this to see what tables you have available. Those are all the ones in pink. Those are the tables that are present and have data. The purple are data that are tables that are present but have no data in them. And then the green are tables that are just not present at all. And so you can quickly visualize what are you missing from your database, and are these different tables important for the integrity of your data model. We also do a quick data characterization of your database to show the different sizes of your different tables and represent them by color in size of gigabytes, as well as the size of the square, I believe, is the number of rows in each of your databases, or each of your tables. So this is just to give you a quick summary of the relative size of your common data model. We also do, so for the use case here, DataQuest will get data loads quarterly, so every 3 months they get a new set of data that combines their old data with the new information from all the different clinics. And so it was important to understand how the data is growing and whether we're actually getting the correct data over time. So in this case, every time you run the tool, it saves all the reports to your report folder. When you run it again, it will pull back any old information you have and compare the size of each of your tables to the current size of the table. So you can compare across time how your databases are growing. In this specific case, on May 15th, I had an OMOP database that we didn't think was complete, and so I was able to email the people who were supposed to be loading the data for me. They got an email back saying they had reloaded all the information correctly. I was able to run it again, validate that all the tables were in fact back to up to the point where I thought they should be. So I could just very quickly go over each of those tables without having to manually recode all the different analyses. And that's for the UW OMOP repository. So DataQuest also uses these on a quarterly basis. So the next one, this is just a pretty simple missingness test. So we just go through every table and every column, and we assess what percentage of your columns are null, and what percentage are some nonsense value based on some definition that we've defined as a nonsense term. So an @ symbol, exclamation point, things of that nature. And the way we visualize this is we just visualize every single one of the tables and columns and show what percentage is null and what percentage is nonsense. So the pink are null values for each row, and the blue is the nonsense values. This has been pretty helpful for us recently. We've been trying to put on a pretty large project with our OMOP repository, where we are doing a community challenge where we're asking participants to submit prediction models that have been Dockerized. We want to be able to train and predict behind a firewall without them seeing the data. So I've been actually using these tables to help build metadata around which columns are empty or which columns are useful for participants, so they're not having to. So they have some information on how to work with our data without actually being able to see it. And so just a quick example of what this looks like. So here's the HTML table, but you would have these visualizations of missingness across all the different tables. So here's domain, concept relationship. So you could kind of visually see, you just scroll down really quick and see where you have big problems. Drug exposure is a big problem. You probably want to go back in and figure out why you have so much null values in that table. And then we do an orphan key test. This is simply do you have primary keys, do you have foreign keys that are not present in their primary table? And we do this check across all the different clinical tables. So this is how we present this information. So in the top table, there's no red, so you could probably just skip on by. But what this is telling you is that in each of these tables, the green columns are the number of IDs that have been found in the person table. So these are person ID that have been found in person table. So you have a good clean, so you have no orphan keys. And the second one we're looking at, it's the same one, but for a different for a different repository, where you have a bunch of person ID keys in the observation table that are not found in person. And so so I think this is still an ongoing issue actually. So we have to go back in and figure out why we have so many orphan keys in observation. And then finally, at the moment, we have the indicators data quality assessment module. And this is just to look for specific key clinical indicators that we at the individual sites have decided are important measures for how complete our information is. So this is essentially saying for each of these variables, what % of patients do not have one of these measurements. So for HR, our heart rate, 78% of our patients in this repository do not have a heart rate measure. And so we can go through and look at, 78% do not have a condition, 82% don't have a medication, and you can go on and on. We've made this really easy to add new tests for. So there's a, we call it the indicators. There's an indicators.json file that basically each of these tests can take 5 variables. And so there's 2 ways you can add one of these indicators to this module. You can add one where you can add a set of concepts to check for that individual column. So basically the way the test works is it queries the table. So in the top one here, we're looking for heart rate. So you'd want to look at the measurement table, and then you want to query which column in the measurement table, so the measurement concept ID, and then it's going to cross-reference all those, every concept in there against whatever concepts you place in this list here. And so in this case, this is 423408, and I believe it's a SNOMED code I think it's a SNOMED code for a heart rate measurement. And it would just check how many people have this concept. The other way you can add an indicator test is just by labeling concepts false. And all that will do is go through the same format, looking at the table, looking at the column, but then checking to see whether it's a null or non-null value. And so it's just going to be checking to see how many people have non-null values in that column. So you can add 2 different types of tests to this. This is mainly just to look for records on the bottom or specific concepts on the top. So just as a quick use case, let's say you wanted to ask how many people have hemoglobin A1C measurements in your repository. So you would just add your indicator name. You'd want to be querying the measurement table, and then you'd be looking at the measurement concept ID column. And then you'd have to go, I just pulled these from Athena, and I went through and looked for, these are all LOINC codes, or the concept ID for LOINC codes for hemoglobin A1C lab measurements. And so then when you run this again, it will just simply, it will add in one more line for hemoglobin A1C, and you can see 86% of our patients do not have one of these lab measurements. That could also be that I missed one of the concepts. But at the moment, of these 7, 8, 6, whatever it was, of these 7 concepts, only 96% are missing one of those. So you can imagine that if you have a specific question in mind, you can just keep adding these on just one block at a time, and you can run these and kind of see. This is kind of one of those fit for use cases where if you have a specific study in mind, you would look for specific lab values or specific measurement types. And so then once we've combined all these reports together, we output a visualized report. And so you can just go through and skim through each of these things manually. So here's our orphan key tests, our clinical indicators, and then I've done some other stuff here, but I'll get into those in a second. One thing that we do visualize that I didn't talk about is kind of the overall relational model. And so the blue tables, or the blue circles here, are tables that are missing, and the pink are tables that are present. And this is just conceptualizing how all the foreign key and primary keys relate to each other into the different tables. And so ideally, you just use this to see whether you have any central tables that are missing from your repository that are not that you would hope to be present there. So you can kind of go back in and look at your ETL. Yes, so once you output all these reports, we also have a network assessment tool. And so the way this tool works is when it runs each of these individual, when you run, let's see here. So when you run this first section, each of these reports is output into its own folder underneath an individual site's name. So for instance here, there's 4 sites. There's 3 sites from DataQuest and 1 site, the University of Washington, which is our OMUP repository. And every time you run one of these sites, it outputs the date that you ran that underneath that site, and then in each of those date folders, you have all the reports that were generated from that run. And so every time you run these, you'll get these new reports. And so that's how we load the different data loads across time, is from each of these individual folders. But we also have a network assessment tool that will pull all the different sites and all the different reports, or the latest report from each of them, and will combine them into a single network assessment dashboard. So this dashboard has a series of aggregated visualizations to kind of give you a snapshot of how the completeness health of your network, if you will. So in this first one, we've taken all those table present and absent reports and combined them, and you can see which of your what percentage of your network, or how many number of sites are missing a table or have a table present. So all of them have a person table, location table. Some don't have a death table. So that's kind of how you can see and figure out which tables you need to actually go into and look and figure out which site is missing the different tables, or if that's an acceptable threshold. The other thing we do is we look at loads over time at all the different sites. So every time you run, so this is just pulling all the load sizes for every time you run the tool by date, and you can see over time which of your sites are growing, which are stagnated, or which ones you've kind of neglected. That little red dot there, we've only run him once. And so you can compare them over time, overall, what is your network doing and how is it changing? And then we also combine the missingness tables, or those missingness reports that we showed. And so the red is the average missingness, and then the individual smaller dots are individual sites. So you can figure out whether your whole network is pulling down a missingness, or is missing a ton of information in the column, or if it's just one site that's pulling down the average. And so you can go further explore those across your network. And then we also aggregate indicators across the network. So the red dot, again, is the average missingness for each of these indicators. And then the little gray dots are individual sites. So for instance, in observation, we have a cluster of low missingness sites, and then one that's pulling down the average. In this use case, we'd probably just go to the individual site and figure out why so many other patients are missing observations. Maybe the ETL's been wrong, or all the information's been put into measurements when it shouldn't have been, things of that nature. We can start exploring individual sites for this stuff. So then finally, we've tried to make it easier to add new modules to this tool. So if you're not a programmer, you can kind of ignore this, but essentially you can just add one Python class. And then we've built this query object that you can use to manage how the reports are being output and designated. And so we have a lot of documentation around that we've put some time into to help facilitate that. So one thing we've been working on for new modules is just a data characterization for vocabularies in our data sets. So we were having problems with different which vocabularies were being used in the different tables. So in this case, you can see we have mostly compliant vocabulary except in the condition occurrence table. So in this case, I was able to go into the condition occurrence and start mapping all those ICD-9 and ICD-10s to a more compliant standard, specifically SNOMED. And when we ran it again, we can compare the two tables, and we see condition occurrence. We're all SNOMED, we're all clean, we're all happy. And then I believe HSPCS is not a standard terminology, but the code in there is not mappable to a standard, so we have to leave it there. The other one we've been playing around with, this is one where the vocabularies, there's a lot of different vocabularies, and there's a lot of messiness we have to go through. But this is something you could quickly and easily run, and just to get a quick picture of how much work you need to do to get your vocabulary or your different tables up to the OMUP standard. And then another one we've been playing around with is just temporal plausibility. I believe you can do this in Achilles, but this was something that that DataQuest wanted with this tool, so they could quickly see where their data is ending and where it's beginning. In this case, it's looking like 2010 is probably the cutoff for where our good quality data is beginning. And so we probably just cut off everything before that, since everything's been going to 0 and conditions start in 2010. And then we also, with this tool, we also have a standard operating procedure document that goes through each of these visualizations, kind of describes how you would use each of these, or how you would follow up on each of these tests to improve your data quality. And so that's available on GitHub that you would use in combination with this tool. So that went a lot faster than I thought it would. But anyway, we're looking for people who are interested in helping contribute, or if you have ideas on how to improve it, or just to test the tool out. If you're interested, you can email me. You can go to the GitHub. If you're having problems with that, email me and I'll help you set it up. This was made possible by CD2H, or the National Center for Data to Health. They put some resources into revamping this tool with the goal of using it across the CTSAs. And then ITHS also is the Institute for Translational Health Sciences at the University of Washington was also instrumental in making this possible. I'll take any questions at this time.
Is this one another tool that just you schedule it? You can schedule it every day to run, and are you running it against a aggregated data set, or are you running it on each site and then putting the data together?
Yeah, so we're running it on each site. So the nice thing with the config file I mentioned in the beginning, the way I have it set up is I just have a config file for each of the different sites. I think we're a little unique. I've been talking to people, and I think we're unique in that we have our repositories in different locations. So for instance, DataQuest is in the same database, but different schemas. UW is in a whole nother database and its own little VM. And so all these need different configurations. So if you wanted to do a scheduled run every single day, you could do something as simple as put all your configurations in one folder and then have a cron job that will run, Python DQEC, star configs, and then we'll just run all of them, every day or every other day, however you want them. So.
And then to create new modules, are you using like a SQL Alchemy ORM is this database agnostic is what I'm trying to get at?
So right now, the tools we have are work on SQL Server and Postgres, and we think they work in Oracle. We haven't fully tested on Oracle yet, and also on Redshift. So when you add a new module, you do have to take that into account. That is one, I think, weakness of it. We're building it to be database agnostic.
Okay. Just a suggestion: if you never heard of SQL Alchemy, it's a great way to make it database agnostic.
Okay.
Yeah.
Great questions. Who else has questions or comments? So the indicators that you showed, is it possible to put logic in there so you can define a new indicator, right? And have the list of codes, and it's going to come up with a level of missingness for that particular thing. Is it possible to have two different things combined? So either any of these or any of these, or does it have to be a single?
At the moment,
entity,
it's just a single list.
Single list.
Yeah,
it's still very useful.
Yeah.
And have you used it in the way you kind of alluded to its possibility of being useful if you're trying to figure out how you might define a data set for a particular analysis? If you created indicators for each of those, it would give you a sense of how much missingness there is or how many people are present. Have you done that?
Yeah, we've been working on that. So we've been trying to figure out how useful this data would be for the upcoming or our competition that we're trying to run on this.
Yeah.
And so we've been looking at specific indicators for we're asking for people to predict mortality prediction. So we've looked at individual indicators of that to see whether it's feasible. And so far it's been pretty good. We missed like there's a couple of weird things that we were missing, like height and weight, that we've had to go back to the people who did the ETL to figure out why we're missing, obvious indicators that we would expect.
And do you want to describe the contest a little bit for folks?
Oh, sure. So if you're not familiar with Sage Bionetworks, they're a nonprofit up in Seattle, and we're running a dream challenge with them. And a dream challenge is just a community challenge where we ask one question, and we have one set of data with a gold standard answer, and we have a bunch of people compete to see who can answer the question closest to the gold standard. So in this case, we're using UW's OMOP repository, and we're having people predict 6-month mortality for individual patients in our data set, and we have a gold standard that we've been able to map to a state death record. So if anyone's interested in competing or being on a team, you can go to synapse.org and you can search for the EHR Dream Challenge. I think you can also just search it, EHR Dream Challenge mortality prediction. And we're very excited about it. We're currently in the open phase, and we'll have a webinar on how to participate on Thursday. So if anyone's interested in that,
There's a $10 million prize, isn't that right?
I don't know. Sure. Yeah. Yeah. So.
No, that's very cool. And is it possible to go through the documentation a little bit? Because I think that's a really wonderful thing to have produced to go along with this. It's
Yeah. So we just simply go through on how to basics how-tos with Git repositories, what different channels you're going to need, especially if you need to use Oracle. You have to adjust your Conda configurations accordingly, how to install the different dependencies, and then how to configure your configuration file to make it run correctly. And one thing I didn't add, it's pretty straightforward to add a new common data model, or at least a common data version. So basically for each of these new OMOP versions, you can download. I've been downloading the CSV files from the GitHub, adjusting them slightly. I was actually very excited to see Ajit talk about the different CSV files they're going to be releasing with new common data versions, because I was looking at those and seeing that a lot of the stuff they'll be adding is what I've been using for this tool. So this tool should integrate very nicely with any future releases of OMOP. It's just simply you add one CSV file into one folder, and you make a reference to it in one of the modules, and then it will pull everything in and run all the tests on that CDM pretty cleanly. So we just have an outline of how our workflow works, and then a description of each of the different modules that we've been running. We also have instructions on how to add clinical indicators to your tests so you can get that for your information, and then an outline of how the summary reports are working. And then also for each individual site, you can there's options. If you don't want to visualize anything, you can just run the tool, and there's a command line option -V to set whether the visualization is generated or not. If you want to pull that in and then do it later. So there's all sorts of different options there. We also have a wiki that we've been building out to help to talk about how to add new common data models or adding new rules. So if you want to add a new rule, this is just going through how each of these work. Each module is set upon the query module that we built, and so this is just a detailed description on how you integrate with the current workflow.
And I misspoke actually when I said the documentation, because this is the documentation. I meant the SOP you mentioned at the end that had been developed, because I think one of the things that's useful that we can all learn from, I think, is how this has functioned within a network environment, and so not only showing kind of a little bit more about what is there for the standard operating procedure for using it, but kind of the roles of people in the network and how that's gone. If you have reflections on how well that's worked or lessons learned about it, I think those are all useful things to cover.
Yeah. So unfortunately, I'm more on the development side. So the admin side, I'm not sure exactly how that all works. So
fair enough.
I would love to speak to that, but all right, whammy, data quest. Oops, wrong one. So do keep in mind, this one was for the slightly older version of DQEC, but I think it does hold. There are efforts to update it for the most recent one. So hopefully we'll get a newer one here pretty soon.
Well, I'm sorry to spring that on you out of the blue. I just, we didn't have questions, and we have some time, and I think it's a really valuable contribution. I wanted to, I know you can't speak at great length about the structure. Oh, you've got it open now.
Yeah.
I'll let you go ahead and do that.
So it just goes through each of the different tests and each of the different tables, what's being reported in each of these tables. Yeah. So it's just a documentation on how to use each of these. What's the use case? So we have size. So this is the table that is reported from the table list column or from the table list procedure. And this is just a item by item description of what each of these are describing. And so it goes through test case by test case. I don't know. I'm not sure we want to read through it, but you can go ahead and read. It's available on download, and it's on the last slide, and I'll show that at the end.
Great.
So,
great.
So.
Well, any more comments on a general?
So in your options for you've got several different OMOP data models, but you've got some PCORI models as well. Mm-hmm. What if people have other databases that don't fit in those categories? What's the level, feasibility of being able to run the same sorts of things against other databases, and what would that process be?
Yeah, that is one we were working on. We've actually been talking with some I2B2 folks to see if we can work on getting it integrated. The basic, the way you would do it is the same process for adding new versions of OMOP is pretty much the same for adding new common data models. So all we expect is a CSV file for the table, all the different columns in that table, and then we just need some designation on which are the primary keys, what are the categories, and then from that we can run almost all the different modules against that common data model. So you just need a description, and then there may be some tweaking on for the indicators, considering that some of the tables are going to be different named, but it should be pretty easy to adapt to transition into a new one. Do you have another common data model at your site you're thinking of, or?
No, I'm just thinking even outside of common data models, that if you happen to have your own warehouse and want to run something comparable against it, it would have different code sets and so forth. Right. But some of the tests that you're doing are very convenient.
Right. Yeah.
Sorry.
I have a question about your visualization tools. There was a very nice visualization of the data model in a graph type. What are you using, and what's the backend? And the second question, what are you using for the outcome visualization? And also, have you, I understand that it's all web-based, right?
It's what-based?
Web-based. Your visualizations.
It's an HTML file.
It's HTML files. Have you considered plugging Tableau?
Yes. So we've purposefully separated the visualization aspect from the rest of the tool. So if you have a better dashboard you want to build on top of the reports, go for it. But the one we use is Knitter and R Markdown. And so you can do all the calculations in R Markdown and output the visualizations, and then Knitter will stitch it all together into an HTML file that is output. We've played around with a little bit of Tableau, but I haven't put a ton of time into making a nice dashboard with it.
And the graph?
Oh yeah, the graph is, it's R-based. I think it's a ggplot function, and I think it's called viz something. I can look in the.
And the backend for that?
It's ggplot.
No, the data.
Oh, the data. I pull in, okay, so in the CDM configuration files, you have your tables, all the columns in that table, and then you have the primary and foreign keys. So we map those together and create a graph.
Slight concern that I have is that we have two different tools, and is there a way to merge them into a single set of tools that we don't have to run something, and then we will show, oh, we have great quality here, but then someone is saying, but you are not measuring something else there. So is there a way for you guys to talk to each other?
We've been talking. We're thinking. Yeah. So no, I think that is a very general concern, and I think we're all concerned about it. That we don't want a bunch of different data quality tools popping up. I think originally when we did DQEC. I think Achilles was in very early stages of development, and when our team went and tried to use Achilles for their data quality assessment, it just wasn't quite what they needed, and so then of course they went and built their own tool, and so I think we're getting to the point where we're getting enough of some really good tools out there that I think if we can combine them, I would like to combine it. I think that'd be useful, but I don't know exactly how we do that just yet. So.
Java, Python.
Yeah, exactly.
How difficult can it be?
Yeah. I think there's a couple over here.
Just going to say, when it comes time to decide on, what language you're going to use to combine them, do you want champions to come wrestle for you, whether it's R or Python?
Yeah. I mean, this tool was originally in R, and I'm just better at Python. So maybe that was a mistake on my end. I don't know.
Hello? There it is. Our intent is to make a Java library out of this so that you could call it from different languages. So there's a little more extensibility with that, but we didn't have time for that. So, but we will change that. The intent was to make Pavel happy, but maybe as we further discuss where there's opportunities to kind of combine the tool, it might make sense to have like a Java library. It's going to be a lot of painful work, but I think it might be a good way to make sure that we can all be happy potentially, even you, Siegfried.
I think there's one back there.
So curious on how you deployed these across all your sites. Was it just a simple download from the GitHub and install it onto their servers? And what kind of challenges did you come across when going through? How many sites were there?
5.
5? Okay.
But so it's a little getting me to run these, I just got SSH access to a lot of the different servers, and I could run it from my computer, and I could just port in, run them, and then I would have a lot of the reports. So I've been getting them. I've actually been working on getting them implemented on other people's computers, and that's always fun. The biggest problem, honestly, was getting Anaconda working correctly on their. They didn't have Python even installed, and so getting that all configured was actually more of the nightmare than getting this up and running. This is pretty straightforward once you get Anaconda set up. It's just a git pull, and then you use the built-in Conda requirements, download, and then you just run. I mean, it's once we've gotten Anaconda working, the tool ran really, really well, and so that's been the hardest part. The other nice thing is if you don't have access to all the different repositories, but you still want to do the network assessment tool, you can have people run it at their own individual sites. They could email you the folders or some other method of transport, and you can combine them into your own report folder and then run the network assessment tool on that. So you don't have to run this end to end. We've blocked these out purposefully so that it's a little more customizable and adaptable.
Just to make sure I understood what you said earlier, you're saying that as long as I have the table columns and relationship keys, I can point this to whatever and I'd get those reports?
if you run, let's see here.
So like if I had a VDW, I can do that?
In theory, yes. So here's what we expect. We expect table name, column name, and then whether that column is the primary key in that table, and then the abbreviation and the category of what that table is. So is it a vocabulary? Is it a clinical table? That's, observation of person.
Okay.
This is all we really expect. And so what you can run, the missingness, you can run the differential one, you can run orphan. What will break, I believe, is the indicator test. And so for indicators, you would just have to, let's see here.
But you can define that with your specific thing, right?
Yeah,
That
so
you
indicators.json, and you would just, for each of these, you would have, if you have your own custom thing, you would say, for blood pressure, I know, I need to change the table, the column name, and then whatever concepts we're using.
Whatever, like a value set kind of
Yeah,
thing.
exactly. And so,
Okay.
you'd have to do that for each of these, so it'd be a little tedious, but I think, but this would be it. So you would do that, and then you do this, and now you can run this on whatever you've set up.
Very nice.
Yeah.
Okay. How about a big round of applause for Tim? So we're ending a little bit early. Why don't we come back at, let's see, 2:45, and then we will have more time to go into PedsNet DQ Toolkit when you get back. And if that runs short, which may or may not, then we'll have more time for getting everybody's input on steps forward at the end. And in any event, it's going to be a great rest of the afternoon. So we got another 15-minute break now.